morning. Our next topic, chapter 4 on infrastructure. So what is infrastructure? Infrastructure can be defined as the basic facilities and systems serving a city or a country. It is all the services and facilities needed for the operation of a society. So the infrastructure including retaining walls, roads, drainage, sewerage, water supply, solid waste, power supply, and telecommunication. So all this is infrastructure in construction industry. Okay, a retaining wall is an earth retaining structure that retain earth behind it, and retaining walls are designed to hold soil to a slope that is not natural for construction purpose. And during design retaining walls, there are design that need to be follows. There are 4 things, which is no overturning should occur. Sliding doesn't happen. The soil on which the wall rests mustn't be overloaded. And the material used in construction are not overstressed. And this is types of retaining wall. This is an example of gravity wall. This is gravity wall, okay? This is gravity wall. And this is a precast concrete wall. Okay, this is precast concrete wall. And this is an example of gabion walls. And this is an example of RC walls. Other than that, we also have this one. This is an example of sheet pile walls. And this is mechanically stabilized MS walls. Okay, so MS walls have different kind of shape, which any shape that mechanically stabilized. And this is a slurry and secant walls. Okay.
Creating secant walls is easier using EPS forms. Universal Foam Products can quickly and accurately quote you on your EPS secant forms. With over 30 years experience in construction applications and over 80 shipping points nationwide, Universal will provide you with recommendations to make your secant form installation easier, faster, and more accurate. The process starts with the construction of a shallow guide wall. The EPS forms are used to shape the inner curved face of the guide wall. With the reinforcement in place, concrete is poured around the forms to complete this stage. When the guide wall is strong enough, the primary or female piles are constructed. The piling rig drills straight through the forms to achieve accurate placement. The primary piles are drilled out with alternate spacing to form the intersecting design required for a secant wall. The piles are then filled with the first of 2 different concrete mixes. The secondary or male piles are now drilled out. This action creates the important interlocking overlap between the piles. For reinforcement, a prefabricated steel cage is lowered into each secondary pile. A second hard concrete mix is then used to complete the wall. Some specifications require all piles to be made of the harder concrete. A secant wall completed to precise tolerances.
So that is a secant wall. You can see how they install. They have 2 secondary and primary walls, which is sometimes they call it as male and female walls, which are different by the reinforcement bars. And next is soil nailing.
First things first, what exactly is soil nailing? Soil nailing is an effective geotechnical technique used to stabilize slopes, retaining walls, and excavations. It involves using steel or fiberglass elements, known as soil nails, to reinforce the soil and increase its stability. Now, let's talk about how soil nailing works. The process typically begins with drilling holes at specific intervals and angles into the unstable soil or slope. These holes are then filled with a grout mixture to form the soil nails. The nails are usually made of high-strength steel, providing the necessary reinforcement. Once the nails are in place, a corrosion-resistant steel or wire mesh, called a facing, is installed over the slope or excavation face. This facing helps distribute the applied loads and further reinforces the soil, preventing it from collapsing. Soil nailing offers several advantages that make it a popular choice in geotechnical engineering. Here are a few key benefits. Versatility. Soil nailing can be used in various soil types and ground conditions, making it a versatile technique. Cost-effective. It often proves more cost-effective than traditional stabilization methods like shoring or deep foundation construction. Minimal disruption. Soil nailing requires minimal excavation and disruption to the surrounding area, making it ideal for projects in urban or confined spaces. Faster construction. Compared to other methods, soil nailing can be quicker to implement, saving both time and resources. You might be wondering where soil nailing is commonly used. Well, here are a few applications. Slope stabilization. Soil nailing is an effective technique for stabilizing slopes prone to erosion, landslides, or slope failures. Retaining walls. It's often employed to reinforce and stabilize retaining walls, preventing backward movement or collapse. Excavations. Soil nailing provides temporary or permanent stabilization for excavations, ensuring worker safety and preventing soil slippage. And that's a wrap on our exploration of soil nailing. We've learned what soil nailing is, how it works, its advantages, and where it's commonly used.
Okay, that's about soil nailing. This is an example of reinforced concrete walls. The RC retaining walls are gravity structures in which the stability against overturning is provided by the weight of the wall, reinforcements bars in the wall. So that's why we call it as reinforced concrete walls, because they have RC bars inside. Okay. So this is a reinforced concrete wall where we have the stem, and also inside we have the reinforced concrete and also foundation connected with the foundation. The method of construction is first you need to setting out and preparation of the base, and then use a string line and excavate the area by removing all surface, and formwork preparation, rebar installation, inspection, concreting from work, formwork removal, and curing of concrete. And also should install the drain pipe as required, and perform backfilling and compaction of soil accordingly. This is a creep retaining wall. They are a form of gravity wall also. They are constructed of interlocking individual boxes of precast concrete. This is the boxes. Okay, the main hole it. Then the box are filled with crushed stone or other coarse granular materials to create a free draining structure. So this is the example of the process. Okay, I have a video here. That side. Yang ni tak ada suara ke? Ini. Itulah proses dia. Dah siap susun, barulah sekali dia backfilling kat belakang. Tu, nampak tak? Laju sangat. Nampak tak dia tengah isi ni? Okay, kita tengok dekat slide. Okay, first tadi dia buat base footing installation, and then they built the wall course by course, and then backfilling. Okay, you see the excavator just now, they pull inside the courses with gravel inside. So they do the backfilling, the retaining wall drainage, and then finish. So in the advantages of grid wall is that they have this soil so that any plant can grow. So here is the example of vegetative grid wall. Okay, and then we also have the gabion retaining wall. There are multi-seal rectangular wire mesh box which are filled with rocks, okay, or other suitable materials, but usually they have rocks that actually you need to arrange.
Excavate the foundation as per the area required. Levelize and fill the excavated area with approved material and compact. Assemble the cages as shown in the illustration and place on the foundation. Staking of the gabions may be done to maintain the established proper alignment prior to the placement of rock fault text. Fill the gabion cages systematically with approved rock material. Carry out a geotextile fabric installation on the backfill side of the gabion. Geotextile will prevent clogging and allow water to get through a gabion wall. This will ensure reduction of poor water pressure on the gabion retaining wall. Place a perforated drain pipe at the bottom of the gabion wall as shown and backfill using granular material like aggregate. This also allows the drain of water from the backfill or retained soil, hence reducing poor water pressure. After the drainage process and after granular material backfill, carry on the backfill with the retained soil and the gabion installation procedure.
That is an example of gabion construction, where you actually need to level the bed on which the gabion cage are to be laid, and then lower down the gabion basket. Just now you see the step by step. And then the gabion will be stretched to remove any kinks and to gain a straight alignment. Gabion basket shall be wired together. And after that, the basket shall be filled carefully with the rock in layers and stages, because they need to face the permukaan yang rata tu dekat wire tu. So we actually need to carefully arrange the rocks, and internal cross tire wires shall be placed in each gabion so that the cage tu dia tak runtuh bila kita letak, mesti ada wire kat tengah. And also membrane is used to cover the rear of the basket, and also the backfilling can take place as last step before grass laying. So this is step by step of retaining wall construction process on the gabion retaining wall that you've seen just now in the video. And actually we have finished part 1. Also together with the slide, I also prepared additional notes, okay, additional notes for you to read.